Just like with segment addition, where the sum of the parts is equal to the whole, the same is true for angles. So if I have angle ABC with ray BD in its interior, okay, it's not bisecting it necessarily, but it is in the interior. There's three relationships that you can conclude from this angle. This pair of adjacent angles 1 and 2 are going to add up to equal the whole angle ABC. So this is kind of your typical angle addition postulate. Okay, so when I justify it, I'll usually use just an angle symbol and then a plus symbol. And if you're typing this in online, you might have to spell out angle because it's not real convenient to write in an angle symbol online with what we use. But this is kind of your basic angle addition postulate. Now, just like the segment addition, there's two variations off of this. They're both based on the fact that if the sum of the parts is equal to the whole, then each individual part is equal to the whole minus the other part. So again, this is just like with the segment addition. You have the relationship that the whole is equal to the sum of the parts, or you have the relationship that the part is equal to the whole minus the other part. This is still considered angle addition, even though there's no plus symbol in it. And so when you're working with this kind of problem, the same things hold true. Okay, so if I told you you have the following information, that measure of angle 1 and measure of angle 3 are equal, can you prove that angle ABD is equal to measure of angle CBE? Okay, so when you're looking at this, again, my statement and reason charts, I'll just abbreviate with S and R. My first statement will always be the given information. Angles 1 and 3 are equal. Okay, and then I can move on to my next step. Well, I want to introduce my end state elements as early as possible. So again, it's the same systematic process. So let's see if I can introduce angle ABD in terms of what's already there. So here's ABD. What is ABD in terms of 1, which was already introduced in the proof? It's equal to angle 1 plus what? Angle 2. So that is angle addition. At the same time, you can introduce the element CBE, the other end state element. Here's CBE in terms of the angle that's already provided. Angle 3 is already in our proof. So angle CBE is equal to measure of angle 3 plus measure of angle 2. Okay, so again, similar way that we looked at those. And just like with those couple examples that I did, we have two options here for statement 3. How many of you guys see the substitution method? So the right-hand side, how many of you does this make more sense? Okay, how about this, the adding and subtracting values? Okay, so I'm assuming the other ones still doesn't make sense at all. Okay, so you do have to kind of choose one or the other. Okay, so I saw more hands with the adding and subtracting, so that's the one I'm going to demonstrate here, but it's not the only method. Okay, so in order to get these two wholes equal, ABD and CBE, we have to set their parts equal. So if we rewrite equation 1, angle 1 is equal to the measure of angle 3. what do I have to do to angle 1 in order to get this form? I have to do what to it? Add angle 2. And if I add angle 2 to one side of my equation, I have to add its equivalent to the other side. So the equivalent is either angle 2 or anything that's set equal to angle 2. Well, which one do we need in order to create this statement here? We can just do angle 2. We can add angle 2 directly to both sides. When you add something to both sides of an equation, that's simply the addition property. And then you can conclude with your final statement, what does angle 1 plus angle 2 equal? We can replace it with ABD. And then angles 3 plus angle 2 is equivalent to angle CBE. And so by substitution here, again, not transitive property. Transitive property implies that two things are equal to the same thing, therefore they're equal to each other. Here we just substituted in values. And so we ended up with our final statement in those 4 steps.